Okay, so today's lesson we are going to talk about place values and numeration. So overall we're going to be able to identify the values of digits, both whole numbers and decimals. We're also going to have some practice with reading those numbers. So let's start with 4 digits. I use the term digits here very specifically because you might say 4 numbers. However, we're going to talk about why the placement of each of these digits is so important in forming a number. So while we have 6, 1, 4, and 6 here, really these are just symbols until we place them in a particular order. So if we kept them in this order, these digits would form the number 6,146. However, my placement now shows 1,466 as the number. Same 4 digits, however, a very different number. And throughout the lesson, we'll talk about why the order is so important and why where we place digits help us to determine what our number actually is. So we're starting with our very basic place value chart. This chart only deals with whole numbers. As you see all the way to the right, we have our ones place. And as you're looking to the left, we go from ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, and it will go on and follow a very similar pattern. So if we're looking at ones, tens, hundreds, we call this period or this family the ones family. Thousands, 10,000s, 100,000s, as you would guess, the thousands period or thousands family. Millions, 10 millions, 100 millions, millions family or millions period, while billions, 10 billions, 100 billions will fall under, right, the billions family or the billions period. So let's look at that same number, 1,466. If we look at the placement of that 1 digit, it's in the thousands place, the 4 is in the hundreds place, 6 is in the tens place, and 6 also is in the ones place. Now, of these 4 digits, which would you say has the greatest value? Of course, the 1, which is in the thousands place, because we know as we deal with whole numbers that 1,000 is way more than 6 ones, and we're going to look at a visual representation of that. So if we have 6 ones, I'm going to use these tiny, what we call units, to indicate a single one. And of course, I'm going to use 6 of them to show that I have 6 ones. Now, if I'm comparing 6 ones with 6 tens, I want you to stop and visualize how different those two would look. So while we have 2 sixes here, same symbols, same digits, just by placing them in different places or different places within our chart, we see that we can formulate 2 different representations of the number 6. So our 6 tens, if we're just looking at 1 10, we know that to travel from ones to tens, it would take us 10 ones to give us 1 10. And I know that sounds a little tricky, but if you think about it, instead of 6 ones here, if we had 10 ones, it would be the same as how many tens? Correct, 110. So we're not talking about just 110 though, we're talking about 6 tens. So 6 tens and 6 ones, we see that there's a very distinct difference. Now, if it takes 10 ones to get us 110, let's think about how many tens it would take to formulate 100. Well, if you guessed 10, you would be correct. So if we're representing 4 hundreds, here we're going to work our way down because I don't really have a lot of space up top. So that would be 100 block, or what we consider a flat, which we'll get more into later, but we need 4 of those. So even though the digit 4 is usually represented as smaller than a 6, 4, of course 6 is larger than 4, but if we're talking about 400s, that's very different and actually a lot more than just 6 tens and way more than 6 ones. Now, if we're transferring our attention to the thousands place, we have 1,000. My question to you is, how many hundreds or flats would it take to formulate 1,000? How many hundreds would we need to create 1,000? Let's check. So if we have 100, 200, 300, 400, 500, 600, 700, 800, 900, of course, 10 100s would give us 1,000. So as we're transferring our attention from each place value section, we go from ones, tens, hundreds, thousands. Our number is multiplying by 10 each time. So it would take 10 hundreds to give us 1,000. Of course, we can trade those 10 100 blocks or 100 flats for a cube or 1,000. If we're looking at just the blocks, the different types of blocks, we'll start our attention at the ones. Remember, these little cubes, as we used over the summer, we consider these to be unit cubes. And we're going to say that for our discussion today, this is representing 1. Now, if we're traveling from the ones place to the tens place, well, how many ones or how many units is it going to take to make this rod here, which is in the tens place? Of course, it's going to take 10 ones to get us a 10. So what we're doing is multiplying that unit by 10 to get that rod. Similarly, if we're moving from the tens place to the hundreds place, well, how many rods does it take to get a flat? Precisely, 10 rods, 1 flat. 10 rods is 1 flat. So we'd have to multiply by 10 to travel from the tens place to the hundreds place. Same goes from hundreds to thousands. It would take 10 flats to get us a cube. So again, we're multiplying by 10. Question: if I started at the ones place and traveled to the hundreds place, how many units would it take to create 1 flat? So how can I travel from the ones place to the hundreds place? If you said you had to multiply by 100, you'd be correct. From ones to tens is times 10. Tens to hundreds is times 10 again. So from ones to 100 would be times 100. And if you look at the flat here, you'll see that there are 100 units within that flat, which gives you your indicator that you'd have to multiply that unit by 100. Okay, so now let's look at this number that we have here, and I want you to quickly read this number to yourself. Okay, if you read 5,892,643, you would be correct. What helps us to read this number is simply the placement of each digit. We know that this is a whole number. So all the way to the right, this digit 3, must be considered to be the ones place. And from there, as we read to the left, we notice that each place value will increase by a power of 10. So we go ones, tens, hundreds, thousands, 10,000, 100,000, million. So this 5 represents 5 million, whereas this 8 represents 800,000. 9 representing 10 10,000. I'm sorry, 9 10,000, excuse me. 2 thousands, 6 hundreds, 4 tens, and 3 ones. So now you'd ask yourself, even though the 6 in this case is larger than the 5, the value is still inconsistent because 600 was nowhere close to 5 million. So the placement of each of these digits is very important. We're going to talk about that more as we go on with the lesson. So now let's bring it back to our conversation about units. Here we have 1 glass of juice. Now, if I were to tell you that we're going to travel to the left on our place value chart, instead of 1 glass of juice, we'd be talking about 10 glasses of juice because we're talking about the tens place. Let's go back so you guys can see a visual. So if I'm traveling to the left on my place value chart, I'm going from the ones place to the tens place. So no longer am I talking about 1 glass of juice. The unit is now 10 because I'm talking about a group of 10, or that tens place. So now if I travel to the left again, after the tens is the, you guessed it, hundreds place. So now instead of 10 glasses of juice, the unit now is now 100 glasses of juice, which is a much larger value. So each time when we're talking about a group and we're traveling to the left, we notice that value is getting larger and larger. Now, if we started off with the 100 and we travel to the right, we'd go from 100 glasses to 10 glasses to 1 glass. But 1 is not necessarily going to be our smallest unit. At least when we're talking about the place value chart, we can travel even further. So now we're going to talk about what happens when we're talking about a smaller unit than just one, which brings us to our conversation about decimals. So now let's look at our place value chart again, and we'll ask ourselves, what is the next placement after our ones place? So if we're traveling to the right, we go from thousands to hundreds to tens to ones. So now if we're traveling from the thousands to the hundreds, what is it exactly that we're doing? Well, we know that it takes 10 100s to give us 1,000. So essentially, we are splitting this thousands up into 10 equal pieces. So since the unit is getting smaller, we're actually dividing this time by 10. So as we travel to the right, the unit is getting smaller by a power of 10. Similarly, if we traveled from the hundreds to the tens, well, we know it takes 10 tens to make 100. So in this case, we're dividing by 10 again. Same with tens to ones. We divide by 10 because there are 10 ones that give us 1 10. So now, if we started with the thousands and traveled to the ones, think about how we'd make that connection. How could we travel from 1,000 to just one unit? And you will have to consider how many units it would take to make up this cube here. That's correct. It would take 1,000 units to give us 1,000. So, since it's getting smaller, we're actually dividing this cube up by 1,000. So when we divide by 1,000, we travel from the thousands place all the way to the ones place. And this relationship holds up no matter what numbers you're talking about, no matter where you are in your place value chart. If you're using the place value chart, because it's a base 10 system, it works the same way. So to get from the hundreds to the ones would be dividing by 100. To get from thousands to the tens would also be dividing by 100 because it's 2 spaces to the right. So now what happens when we're traveling to the right of the ones place? Well, let's look at what's happening with the physical unit. Remember, every time we travel to the right, we're dividing when the number is actually getting smaller. So let's start with that same unit. And what we're going to do, we simply took that one unit and we split it up. So we took that one whole and divided it into 10 equal pieces. If we took 1 and divided it by 10, it would give us what we call a tenth. So 1/10 can be written as a fraction or as a decimal. If you look closely, there's a 1 to the right of the decimal place. That would be considered our tenths place. So here would be one piece or one segment that's indicated out of the entire 10, which would show us that 1/10. So now what happens when we take that tenth and we multiply by 10, meaning we travel to the left on our place value chart? So 2, 3, 4, 5 tenths, 6, 7, 8, 9 tenths, 10 tenths. So if we took a tenth and we multiplied it by 10, it would give us back 1 whole. So the relationship works the same. It's either multiplying by 10 or dividing by 10, depending on what we're physically doing on our place value chart. So now let's bring it back to our glass of juice example. If I took this glass of juice and I smashed it up into tiny little pieces. Now keep in mind that the main difference between the image you see here and what we're doing with our place value chart, if you noticed here, all of my pieces are exactly the same. So we're going to imagine that all of these pieces that the glass is being smashed up into are exactly the same size. So now, if we smashed it into 10 equal pieces, each one of those pieces would represent 1/10, and we can write that as a fraction or as a decimal. Now, what if instead of smashing it into 10 equal pieces, we smashed it into 100 equal pieces? Then every one of those pieces would be considered 1/100th of the whole glass. We can write that as a fraction, meaning one piece out of 100 pieces total, or 0.01, where that 1 is in the hundredths place. Now, what if we smashed it up not into 100 equal pieces, but 1,000 equal pieces? Right, this is a very, very small segment. in comparison to the two other units we looked at. So we're talking about one piece out of 1,000,